Physics Paper 1, Particle Model of Matter, Specific Heat Capacity and Specific Latent Heat. For questions involving specific heat capacity and specific latent heat, have a calculator handy. Key knowledge. Specific heat capacity is the amount of energy required to raise the temperature of 1 kilogram of a substance by 1 degrees C. Specific latent heat is the amount of energy required to change the state of 1 kilogram of a substance with no change in temperature. Key equations. For this topic, it'll be important to know two. Change in thermal energy. Delta E equals M times C times delta theta. Delta E being change in energy, M mass, C specific heat capacity, and delta theta being change in temperature. Sometimes I would write this as delta T. Second equation, energy for a change of state, E equals M times L, E for energy, M for mass, L for specific latent heat. Time for a question. Worked example. The air in a room has a specific heat capacity of 1250 joules per kilogram degrees C. The air is cooled from 33 degrees C to 18 by an air conditioning unit. The air conditioning unit removes 6,000 joules of energy per second. Calculate the mass of air per second passing through the air conditioner. Let's write guess. Look at what we've been given. We've been given C, that's 1250. We've been given change in temperature from 33 to 18, so 33 minus 18, change in temperature is 15. Let's write that there. And we've also been given E. Units look fine. State the equation. E equals M times C times delta T. Substitute in 6,000 equals M, my unknown, times 1250 times 15. I want to calculate M, so I'm going to take this over the other side and divide. Type that into my calculator and we get 0.32 kilograms. So here's the GCSE mark scheme. 1 mark given for calculating the change in temperature, 1 for substituting the data into the equation, another for rearranging, and finally for giving the answer as 0.32 kilograms. Practice 1. A condenser, pictured below, transfers energy from the coolant to the air in the building. When the total energy input to the pump system is 1560 kilojoules, the temperature of the air in the building increases from 11.6 degrees C to 22.1 degrees C. The efficiency of the pump system is 87.5. The mass of the air inside the building is 125 kilograms. Calculate the specific heat capacity of the air in the building. Give your answer in standard form. 6 marks on offer here. make use of the guess method. Pause the video and have a go. Practice 1. How did you get on? Did you use the guess method? So let's look at what we've been given. We've been given total energy as being 1560 kilojoules. However, if we look at the question, it says that the efficiency of the system is only 87.5%. So 1560 times 87.5% gives us 1365. So E equals 1365 kJ. We've also been given a change in temperature. (22.1 minus 11.6 is 10.5. And we've also been given mass. Units. Energy has been given in kilojoules. We want it in joules. So we times by 1000. So E is equal to state the equation. E equals M times C times delta T. I've got E. We've got M. We haven't got C. And we've got T. Rearrange to find our unknown. Type that into our calculator and we get an answer of 1040 joules per kilogram degrees C. However, the answer is wanted in standard form. So that gives us an answer of So here's the GCSE mark scheme. 1 mark for using the efficiency equation. 1 mark for giving the useful energy output. 1 mark given for substituting in. Another for rearranging. Another one for giving the answer as 1040 joules per kilogram degree C. And then finally, another mark given for giving the answer in standard form. 1.04 times 10 to the 3. Practice 2. The initial temperature of a mixture was plus 20 degrees C. The mixture froze at minus 1.5 degrees C. A total of 165 kilojoules of internal energy was transferred from the mixture to cool and freeze it. The specific heat capacity of the mixture was 3,500. The specific latent heat of fusion of the mixture was 255,000. Calculate the mass of the mixture. Give your answer to 2 significant figures. 6 marks again on offer here. Both equations will need to be used. Pause the video and have a go. How did you get on? Did you use the guess method? I'm going to start with G. We've been given a change in temperature. 20 down to minus 1.5, so that is 21.5. It tells us a total energy, that's the total kinetic plus the potential, specific heat capacity and latent heat. A lot of information to write down, so I've highlighted that in the question. Not happy with the units for energy, so that is 165 times by 1000 to get it into joules. State the equations. We are going to be using 2 to find the total. So they're the 2 equations that we need to know. Substitute in. First, and second, we're looking at the total energy, so we need to put those 2 together. And then we need to rearrange to find M. From here on, we can put E into the equation. Calculate that, and we get but we need that in significant figures, so the final answer should be M is 0.5. So here's the GCSE mark scheme. 1 mark given for converting kilojoules into joules, 1 mark given for substitution, another mark given for putting the 2 equations together, and then for rearranging, another mark given for calculating mass, and then finally 1 for putting it in standard form. How did you get on?